So I want to make sure I explain to myself how I did this. Basically, when I hit this button, it loads a map. It then traces my path that I took. This is from a TCX file that you can export out of Fitbit. And what it tries to do is have the entire journey last 10 actual seconds on the web page. So, if you run it again, there is a little bit of the gray and the black don't quite perfectly match. It must be some weirdo rounding error. Basically, I know the center of the map and I know the zoom level for Google. And so I thought I did the math right, but it's close enough for what I need to do. I just want to show how I did it. So, of course, I'm doing a do-get in Google Apps script. There's a whole bunch of shit I used to be doing, so I'm just ignoring that. I read the TCX file. How do I do that? So I read a file and I needed to give it an ID. So I've uploaded a TCX file into my Google Drive and I just need to know the ID of it. I get the blob and then because it's a TCX file, it doesn't know how to deal with it. So I do this get data as a string. When I looked at it, let's see, I think I have a copy of it. This is just the very, very beginning of it. Most of the timestamps have a time and then a position, altimeter, distance, which I'm not using, although maybe I should. That's super interesting. And heart rate. So all I'm grabbing right now is let's see, must be up here somewhere. All I'm grabbing is the times, the latitudes, the longitudes, and the altitudes. And then I'm just spitting them out as arrays. So it's just doing some regex crap there. So what happens after you read in the data, now you have the data. One of the things that I need to know is the total time it takes. So I look at the last time getting the milliseconds and the first time getting the milliseconds. So I'm doing everything in milliseconds here. I get the ranges of the latitudes, the longitudes, and the altitudes. So basically this returns an array of three couplets, right? The lowest and the highest lat, the lowest and the highest longe, the lowest and the highest altitude. So I'm not actually doing anything with altitudes here, but that's okay. I get the center of the ranges. So I must have made a function called center somewhere. So I'm getting the center of the center point, so I know where I want to be. And then it looks like I'm not using this at all. So I was trying to do some 3D crap, so you can ignore that. So then I get the map data. So how do I get the map data? So to get the map data, let's see. Well, if I haven't already read in the file, I read in the file. That's what this line here is doing, line 3. Then I'm getting the ranges again. Oh, that's kind of duplicative, but whatever. Make map array of the latitudes and the longitudes. That's making a bunch of markers. Oh, I don't think I'm using the markers. I think I'm only using a path. I recalculate the center for some stupid reason. I don't understand why I recalculated it. I decide to make it's a 600 by 400 pixel map image. This is some crazy math that I was doing, but what actually matters starts here, I think. Yep, these are the lines that matter. So I got this from some cool web pages that were talking about how what Google does is it tries to make all 360 degrees at the equator fit, and when you're at zoom 0. But apparently that's off by 8, and I don't really understand why it's off by 8, but I'm just going to let that go. I think because they originally planned for 256 pixels to fit the equator, so I guess that's where the 8 comes from, because 2 to the 8th is 256. So I'm doing the range of longitudes, and then so this is just figuring out what the zoom level needs to be. Based on if I were to exactly fit the horizontal and exactly fit the vertical has the correction, the latitude correction. There's this really interesting note on the webpage I was at that was saying how normally you would actually correct the horizontal, but apparently Google thinks of it by correcting the vertical. So whatever, I can live with that. But then I say, well, I actually need it to fit, and the zoom has to be an integer. So I'm actually figuring out the minimum of those two zooms. The lower the zoom, the less zoomed in you're in. And then I take the floor of that, right? So neither of those are integers, and then I round it down to the lowest number I possibly can. Then the dx and dy is essentially degrees per pixel. And so it's doing that same latitude correction for dx and dy. Then I figure out where the corners are by going halfway through the pixels to the left and halfway to the pixels up. One's a plus, one's a minus because Canvas does its origin at the upper left instead of the lower left. And then I'm not using either one of these, so that was from before, who cares? And then I set the mat type to be terrain, that's how you get the little shading. Set the size, the center, the zoom that's been calculated, and then I set the path style to be black. You have to do this weirdo null thing, or else it does this really crazy fill. So I did this so that I could change the color if I put multiple on there. Oh, and then you add the marker list path. So I guess the marker list, make map array. What is make map array? Make map array. Where the hell did I do that? See, I'm glad I made this video. I'm not 100% sure how I did this. Make map array. Did I do it over here? What the heck is make map array? Is it under here after all? Make map array. I'm just going to pause till I find it. Okay, I found it. It was for some reason in the TCX file. All it takes is gives the latitude and then the longitude. Oh, it flattens them. Yeah, so what Google needs is the first latitude, the first longitude, and then just a comma the next one. They're not grouped. So you have to flatten it. So, okay, that's what's happening there. So all make map array is doing is making a gigantic long list of latitudes and longitudes so that when I actually use that in the add path, it's ready to go. Then I get the map as an image, and that gets it as a blob, and then there's the super fancy trick. This is the fancy trick. It won't let you pass blobs around, but it will let you pass around a string. And so if you pre-append it with this crazy crap, and then do a utilities thing, whatever, it works. So that's these two lines I would have never thought of on my own, but it does the trick. That I'm just returning a whole bunch of crap back to here. Once I have the image, I get a whole bunch of information. I'm not doing this first point or last point anymore, so we can skip that. Then, of course, I just make the web page, which has not much in it. I just have two canvases, canvas 1 and canvas 2. They're both exactly the same size. They're in a wrapper, and I told the wrapper that it needs some relative positions. Oh, this is actually wrong. Huh, I'm surprised it works. Oh, I wonder if that's the problem. Let me make this 600 by 400 and see if it makes it any different. Save. And then I'm setting both of the canvases on top of each other. I'm just going to see if that change makes a difference. Nope. Doesn't seem to. Has the same errors. That's fine. So that's in the HTML. And then I pass it a whole bunch of information, including the first time, the last time, total amount of time, and I set a global variable called CTX, which I'm going to need here. So once we push that button, it runs init, and it creates an image, fills it with the data URL, and then dumps it in the lower canvas element, canvas 1. So it, yeah, it, yeah, I get all the context. Once the image is loaded, you have to do this because it takes a while. You draw the image, then I set my, okay, that's when my clock starts, and then I say, let's go animate. Then down and draw, what it says is, give me the time right now, and see how much time has elapsed since we started the clock. Figure how many of that is, what percentage that is of 10 seconds. Then say, okay, well then the target time we're looking for is that percentage, the step times the total time plus the first time of the data set. So we're looking in the data set for the index that is just greater than this. So if the target time is greater than the last time, means the animation needs to stop, so just return nothing. So this thing will just stop running. But if we're still in the animation, clear the previous thing. So if I get rid of this line, it leaves a trail behind. You don't want that. Then I say, well, which index is this? I say, well, find the index where that date is just bigger than the target time. I wonder if I should do equals there, but anyways. And so if I'm stopped at a stoplight, it should just stop at that same index for a while until the next index catches up. And then I did some console log because I wanted to, and then I fill a rectangle with get maps XY. So get maps XY basically says, okay, take the longitude minus the corner longitude, the upper left corner, and divide it by dx. Dx is the degrees per pixel. And then similarly for the latitude minus the corner latitude. Oh, maybe that needs the correction. It's possible that needs the correction. Well, I don't know. Divide by dy. And then, yep, it just draws a 10 by 10 little black rectangle. For the moment, it's black. I might choose different colors. And that's it. The whole thing just works. So it's pretty cool. That was interesting. When I went away, it stopped. And so after 10 seconds, it should be my entire roller skate and done. Very cool.